Okay, so here what we're going to do for section 6A.2 day 2 notes, we're going to use the binomial theorem as well as Pascal's triangle to expand the binomial x squared plus y to the third power. Now, first thing is, I would suggest figuring out your a, your b, and your n value. Now, if we go back to the definition of the binomial theorem, they say for any positive integer n, the binomial expansion of a plus b to the n power is as so. So here, this is our a, we have plus our b, and then n is our exponent. So we look at our function here, or our binomial, we have x squared plus y to the third. X squared here is going to be our a value. B is going to be our y value, and our n is our 3. So starting off writing this, we're going to use combinations. Now, since our n value is 3, we're going to use the third row of our Pascal's triangle to help us for our combination. So we start off with 3, choose 0. So 3 is our n value. Now we're going to take our a value, which is x squared. Now with our a values, we always start at the biggest exponent. The biggest exponent will basically be your n value. So since x squared is our a value, we're going to use cubed because that is our biggest exponent. Now we multiply it by our b value, which is y. With our b value, we always start at the smallest exponent, and that will always be 0 in this case. Now, to know if you're doing this correctly, you can always add your exponents, so for example 3 and 0, and make sure they add up to our n. If they do, you're doing it correctly. So if we do 3 plus 0, that should give us n. As well as if you look at your r value, which in this case is 0, that will be also the same exponent on our b value. Okay, now we do our next combination, so we do 3, choose 1. And we multiply by our a value, which is x squared. Now, since we started at the biggest exponent, what we're going to do is decrease. So we go from 3 to 2. And then we multiply by our b value. And here, we're going to increase in our exponent. So we go from 0 to 1. So notice that our r value and our exponent on the b is exactly the same. If we added our two exponents, 2 and 1, it should add up to our n value. Now we do 3, choose 2. Once again, we have our a value, which is x squared. Now, once again, since we're going down in our exponents, this is going to be 1. And then our y, we're going to move or increase. So we go from 0 to 1 to 2. And then our last one, we're going to add our last combination is 3, choose 3. So here we're going to have x squared to the 0 power, and then y to the third power. There you go. Now what we're going to do is you can either evaluate your combinations or use Pascal's triangle to determine these numbers. So using Pascal's triangle, we would use the third row, which would give us 1, 3, 3, and 1. So 3, choose 0. That's actually going to be 1. So we have 1. So that's going to be 1. And now here we have x squared to the third power. Make sure when you have two powers, you multiply it. So we're going to get x to the 6th. And then whenever we have 0 as our exponent, no matter if it's a number or a variable, that's always going to be 1. So y to the 0 power is just 1. Now we do plus 3, choose 1. That should give us 3. And we multiply it. Here we have x squared to the second power. That gives us x to the 4th. And then y to the 1st. Then once again, we have 3, choose 2. That will give us 3 again. Now remember, you can always calculate this on your calculator, or you can use Pascal's triangle to get these numbers. Now x squared to the first power, that will still just give us x squared. And then we have y squared. And lastly, we have 3, choose 3. So that'll give us 1. Now, since this is x squared to the 0 power, anything to the 0 power gives us 1. and then times y cubed. Now, given this, I'm going to clean it up a little bit, kind of get rid of the parentheses. So now I have 1 times x to the 6 times 1. That just gives us x to the 6. And I have plus, for our next term, we have 3 times x to the 4th times y. Plus, now here I have 3 times x squared times y squared. And then lastly, I have plus 1 times y cubed. So that'll give me y cubed. Now notice here we do not have any like terms, so we're not going to combine anything. So this would be our final answer here. Okay, so now what we're going to do is go to actually example 4. So we're going to skip this one and go to example. So here it says find the coefficient of x to the 4th in the expansion of 3x plus 2 to the 10th power. So what we're trying to do is, once again, coefficient. Really that means we want to figure out the number in front of our x to the 4th. Now you could just do the entire expansion and then figure out your coefficient, or we can take the shortcut way. Now our n value here is 10. So when we're using our combination, our n value is going to be 10. C. Now the r value we are not very sure yet. Okay, now our a value in this case is 3x. And here we want to make sure that our exponent is 4 on the x. So that means our exponent on 3x is going to be to the 4th power. And then we have multiplied by our b value, which is 2. Now we still need to figure out what this power is. To know that, remember our two exponents always add up to our n value. So if our n value is 10, and we already know that one of the exponents is 4, well 4 plus 6 in this case will give us 10. So now the exponent for our b value is going to be 6. As I said before, whatever our exponent here on our b value is, that's going to be the same thing as our r value. So here I can put the number 6. So now what we're going to do is evaluate all of our numbers. So you're going to have to put in the calculator 10, choose 6. Once you've gotten that, here with the 4, we're going to distribute that to the 3 as well as to the x. And then we're going to evaluate 2 to the 6th. So putting this, we have 10 combination of 6. So that's going to give us 210. We're going to multiply that by, now distributing this 4 to the 3, we have 3 to the 4th power. That gives us 81. And then we have x to the 4th. Times 2 to the 6th, which should give us 64. So now, 81 is just not our coefficient because we're multiplying by other numbers. So you need to multiply all of these numbers, and this will get you to the coefficient or the value in front of our x to the 4th. So if you multiply all of that out, you should get about 1,088,640. And then this value is going to be your coefficient that's in front of your x to the 4th. Remember, if you have any questions on any of these examples, make sure you come in before or after school, and that's the same thing for the homework. So if you have any questions, make sure you do that.